Okay, so today we're going to be talking about coasts and deltas. So go ahead and log into Learning Catalytics. Log into Learning Catalytics because we're going to be doing a peer instruction on coasts and deltas.
Hey, actually, I have a question.
What's your question?
I got really confused on the deposition, that part, that video. It was the deposition. Let me get out my notes. Probably
Okay, that's fine.
I thought you noticed. I was playing Sneak Fit.
If I get a chance today, I will.
Math, so. Yeah, they did. They're like the kids are playing too many games.
Okay, just have it ready. I'll check those things when y'all are working on this. 'Cause you're going to be doing a barrier island activity, and I'm going to talk about it a little bit, and then you're going to have the remainder of class to work on it. Whatever you don't finish, you'll be responsible for finishing.
Sir, so what are you checking again?
Today I should be checking the activity that y'all did last time. You remember? The lab note. I'm going to check that. I may also be checking your notes if you have them. And then I'm also y'all are going to be working on this while I do that. Okay. Well, tell me a good thing real quick because we got to get going.
Friday.
It is Friday.
Well, I got my resume.
Very good. Congratulations.
So lab note. You're talking
Victoria?
about the 3 pages.
Fall Festival is tonight, so those of you that are interested, stay after.
Barrier assignment and notes.
Okay, that's true.
You got it.
Unless, of course, I guess your birthday was still existing if you did. It's dark, I know. Okay, so the question is, what is a beach?
I'm trying to find it.
And I'm not
Where sand is.
gonna open this one up because we're gonna have to pick and choose which ones we can do. Okay? It's where sand is. I mean, is that the definition of a beach?
No, sir, I was just like.
Okay, there is sand on a beach, but is that always is a beach where sand is? No. Because we have areas that aren't necessarily beaches, right? Okay, so where is a beach normally? It is where sand is, but it's where the water meets the land, and often there is sand. Very good, yes. Okay? Now, the reason why we have sand at beaches is because we do see coastal erosion in some areas. Okay? Some kind of environments will have erosion, and some kind of environments will have sediment being brought to the area by rivers. So it just depends kind of on the environment as to how that sand is kind of made or delivered. Okay? So you can have it from either location. And typically it will get distributed by either currents or waves or even storms. Now, currents are typically tied to areas on the earth where you have higher temperatures and lower temperatures, and heat is going to move from high to low, and so that heat is also going to push water along. So currents are tied to kind of differences in temperature within the ocean, and loosely tied to tides as well. Waves are created by what?
Friction from the wind.
Right. You got to have wind, and that wind is going to then basically interact with that water and make waves. Okay. A lot of people will think that waves are created by what?
The moon.
Right. What are they confusing?
Tides.
So don't confuse tides with waves. Or they might even think that you have like tidal waves, which are completely different. Tidal waves are not really tidal waves, they are tsunamis. And those are created by earthquakes. So please don't get any of those confused because They are very different. Has anyone seen Serena today?
No.
She wasn't an advisory either. How about Brian?
No, but I can text him.
No, I was just curious if he was here. Has anyone seen Abram today? No. Has anyone seen Melanie today? It's quite a bit, yeah.
Everybody. That's what happened last time in another class.
Well,
What class?
if you, yeah, well, hopefully they'll show up.
Seriously?
So, sediment does get moved around. Now, here I am going to send you this question. So on this question, pick all that apply.
There's no session.
Okay, so hit refresh.
I'm going.
It still doesn't say.
Mine's taking a while.
Oh, okay, I see it now.
Yeah, you should see it now, hopefully. And make sure you put in your new seat. Remember, your new seat is the number that's on your table. So just look on your table.
It says wait for the question.
All right, I'm waiting for mine to actually show me something.
Brian's here.
Do you have a note?
I do not.
All right, you are target.
Yes, sir.
Don't make it a habit. Okay,
Hold on, sir.
so log in to Learning Catalytics. Pick all that apply, and I will tell you there is more than one correct answer. Okay? Is it
Yeah,
not
it
there?
doesn't come up.
I'm gonna hit deliver again. Now
Yeah.
try.
Oh,
Kick me out.
It's slow. So beaches can be affected by waves, and they can be affected by currents, and they can be affected by storms, but what other things can affect them? Tides, tectonic processes, biologic processes, sea level changes, and human influences. Pick anything that you think applies. Anything you think applies. If you think it applies, pick it. But you have to pick it. It doesn't pick itself. Am I right?
Yep.
false.
Does it pick itself?
No.
No, it doesn't pick itself. You have to pick it. You must make a choice. So, make a choice and hit submit.
I'm going.
Let's see.
Why does this keep on happening? I have to log in again.
Aaron, are you in?
No, sir. My computer somehow is not connected to the internet.
So reboot. Brian, are you in?
I'm joining it right now, sir.
Moses, are you in?
Yes.
What number are you?
16.
I'm not in. I think.
Okay, sorry. Patsy, are you in?
No, I'm about to leave.
Okay. Well, I want to go ahead and discuss this one. So, continue to try to get in.
Oh, wait, what?
No, that's the round where like no one.
Yeah,
Oh.
no one could see it, so I delivered it again. Okay, so 42% means that about half of you got all of these. And it is all of them. Because the tides are going to make sand go in and out. Tectonic processes are going to affect the coast. Organisms affect the coast, like,
Plant roots.
right? Plant roots tend to make the sand sturdier. They hold it in place. Sea level changes also affect the coast, and then when we build and do things like that, we affect the coast. So all of those processes will have an impact on how a coast will behave. Okay, so sediment will accumulate in coastlines along beaches and dunes. Okay, dunes are going to be basically where the sand tends to pile up more. Along offshore sandbars, this will be kind of like a little island out in the water. And then you'll have things like islands, spits, and other planforms, like you can have a bar. Okay, this is more of a bar right here, and then these things are spits. Okay, kind of where the sand is coming off of the bar. Now, when you look at one of these, notice that it's got several spits. So the next question is going to be, which one do you think is the oldest spit? And the way I would answer this question is I would ask myself, which spit is probably being made right now? You know, based on the way it looks. And I'll give you a hint. The things that are going to make bars and spits are going to be water that's kind of moving this way. Because waves are coming in, say, at this angle here. And there's a component of the wave that's carrying sand this way. So it's carrying sand this way, which means this should tell you which spit is currently being made. If the one that's currently being made is being made, we would call it the youngest spit. Okay? So if you can figure out which one is the youngest, you should be able to figure out which one was the oldest. Okay? But it requires some logic and some thinking and understanding of processes. Okay? Kind of like our river terraces. Which one was the youngest?
The top, the highest one.
The bottom.
Is the one on the left?
I heard both answers. Which one's correct?
It's cutting down to the bottom.
It's the one where the river is currently making it, right? Or the one that the river most recently made. Which one's always going to be the oldest?
The one on top.
The top, because it's the one that the river made first. Okay? So you got to think kind of the same way here. The one that's being made now would be the youngest, and the one that it made first would be the oldest. Aaron, what was your question?
I was asking, does the one on the left have two?
Oh, this thing? This island?
Does everybody have?
No, this is not it. So don't pick it. Okay? This is an island. Okay? And actually, probably what happened here is this bar used to be, maybe this was part of the bar, and a storm kind of came through here and separated it. Maybe. I don't know. We weren't there. We could come up with ideas. Okay, so let's see what people said. We're kind of all over the place. I would like to keep going, so I'm going to talk about it. So this one, the correct answer is right here. This first one. That one's the first one because it had to be made first. This is the youngest one because this is the one that's still being made. Okay? Now, I'm not sure what I'm not sure what this is right here. That's not really anything. I'm thinking they must have just picked the wrong thing. These you're close to right. It just didn't have, it wasn't in the loud area. So I would say all of you are right. These are in the middle, so this is kind of a middle age. These are too young. And again, this is an island.
So they weren't
it's not a
counting
spit.
the ones over there, like next to the green ones?
Yeah, it's not counting these.
Oh.
You got to be careful about those. Okay. So, how does this work? How do we move sand along? Well, you need to understand that it's because of waves, and those waves are going to often come at an angle. So waves don't always come in, directly to the shore. They come in at an angle. And because they do that, you have kind of a component of the wave that goes along the shore and a component of the wave that goes into the shore. Well, the one that goes along the shore is actually going to make the sand move down the shore. We call that a longshore current. And it makes the sand drift along the shore, and we call that a longshore drift. Okay? And it's because of the wave action going at an angle. Now, often you'll have structures like these. Let me see what y'all's next question is. Make sure I got it right. Okay, it's coming up. You have structures called like a groin. A groin is just a structure that goes into the water. But anytime you have a groin, Somebody help out Pablo. The wave action that's coming, say, at this angle here has a component that's going this way, so it's going to carry sand this way, and the sand builds up here, and as it goes around, as those waves go around, they're going to actually dig into the sand over here. And again, we're seeing this picture from where? What vantage point are we seeing this from? This is not a cross section. This is a top view. This is a bird's eye view. So we're looking down at the ocean, okay? So we're seeing sand being moved along the beach, and it's gathering here, and it's being dug up there. So.
Is it underwater?
No. We're seeing this from above. This is above image.
Isn't there
So
a
we're-
picture on this slide too showing a more defined thing?
Here, there's another one. Okay, that's kind of from the side, but we're seeing it from above. So like this one, okay? This is the beach, so we're still looking from above, right? And the water is out here, and the waves are coming in like this. And the question is, what's going to happen? What do you think will happen to the sand when it encounters this structure? So some of it's going to be deposited, and some of it's going to be eroded. Draw what you think is going to happen. Here's your next question. Draw what you think will happen. So if you think on one side it's going to be deposited, show me where it's deposited. And if you think on one side it's going to be eroded, show me where it's going to be eroded. Okay, but the thing that's going to help you figure out which side what's going to happen is pay attention to the wave direction. The waves are coming in like this. Okay? So that should tell you what's going to happen where. Because this is going to block some sand. But which side is the sand going to be blocked? Think about it. It makes sense if you think about it. Did I not send it?
Yeah. It doesn't show.
Hey, try it now.
There it
Okay,
is.
it worked.
I keep thinking I hit it. All right.
Oh, wait.
There is a sketch next time. Guess what it's going to be about?
This?
And the activity we're going to be working on later. So everything that we learned today will help you for the sketch. So you want to make sure you understand.
So it's going this way, like at an angle? Like-
So the waves are coming this way. Okay? The waves are moving that way. My question is, where is the sand going to be deposited, and where is the sand going to be eroded? Okay, it looks like you guys have gotten it. I'm going to go ahead and show results. Slow, but let's see if we can see which I'll put.
Yeah.
It's a little messy because it takes all of y'all's drawings and puts them together. But I think we got it. I can't read it. Okay, so we're going to have an accumulation of sand here. Why? Because the waves are making it move this way. And then on this side, sand is going to get dug out over here. So it's going to have deposition here and erosion here. Right? Okay.
And there's a smiley face.
What did they say?
I can't read it. Does it say erosion? Hopefully it says something appropriate.
Did my fingers be crushed?
Erosion, okay, that would be appropriate. Okay? Now, so it's going to look like this. And here's an actual image. So which way is the current moving in this picture?
This one to the left. To the left.
Yeah, it's moving to the left. Okay? The waves have probably a wave motion coming in this way, and so part of their component is moving that way. And that's why there's sand building up here and eroding here. Okay? This happens along sandy beaches. If you have structures that have longshore currents, this is what's going to happen. So, here's your next question. Let's see if I can do it right this time. Okay? In this question, it's asking you to draw an arrow showing the prevailing longshore current. Okay? So, one thing I'll point out, that longshore currents always run parallel to the current. So your arrow should be what?
Horizontal.
Or I should say parallel to the beach. Okay, so you want to draw a line that is parallel to the beach, right?
What's prevailing?
Prevailing just means the way it normally goes. Like, if you have prevailing winds, that's the way that winds normally go. Like, what are the prevailing winds in Texas, especially in the summertime?
Zero.
No, we have winds. Which way do they typically blow from?
Oh, from the south?
Right, we have prevailing winds from the south. Okay. In the wintertime, our prevailing winds tend to be kind of a mix. Sometimes from the north if we had a front move through, but if it's warmer weather, like you can say, when we have warmer weather, our prevailing winds are from the south. That's the reason why we have warmer weather.
What causes winds?
Huh?
We didn't learn what causes winds.
Well, what do you think causes winds?
Oh my god.
Wind does not cause wind.
No.
Okay.
Right, right. It's really due to differences in air temperatures, differential heating of the earth. But differential heating creates differences in air pressures, and those air pressures create wind.
Why does that such a weird?
This is weird.
Jesus, yeah, Jesus can't always be the answer. Sometimes Jesus can be the answer,
No.
but not always.
Is the arrow staying in one place for now?
Yes.
Yeah, the start of the arrow is going to be in one spot. You just need to drag the arrow in the direction that you think the current would be going. Okay? It should not be hard. Okay? Go ahead and answer. According to this, I still need an answer from Anna, Io, Brian, and Patsy. Have y'all answered? This is not hard. Just point it in the direction that it goes. Okay? Now, let's see how we did. Most of us did pretty well. We got a few funky answers. I think we need to learn what parallel means.
Oh,
Mine's not because it's like, I'm not gonna-
Do we know what parallel means?
Yes.
Away from each other.
Okay.
Yeah, I got it right.
So along the shore is moving this way. Do we agree?
Yes.
So our arrow either needs to go this way or that way. Okay? Okay, it's not going to go this way. Why isn't it going to go this way?
Because that's not.
That's not parallel. Longshore currents are going to go along the shore. Okay, so that's why these are correct answers. That one's too far away from the shore, and these are coming in. They're not going to come into the shore. Okay? Don't draw the way the waves are moving. Draw the way the longshore current is moving. There's two different things. So don't confuse them. Yeah, the longshore current is moving this way. Now, waves are caused by friction, okay, and the length, the height, the water movement, and the depth of influence are going to be affected by wind, okay, and also kind of the overall conditions as well. Size of a wave is due to how much wind there is, how long it experiences that wind, and how long that wind can affect the water. That's what fetch is. So when waves break, they break because you've got wave motion out here in the middle of the water, and then as those wave motion encounters land, the waves start to fall over, okay, and they break. Okay, let me see what the next question is. it's this question. So on this question, you're looking for which shoreline is going to cause the break to be closer. Okay? In other words, where is it going to break at the last moment? Is it going to break at the last moment when you have a shallow shore, when you have a medium shore, or when you have a steep shore? Okay? And think about it. It's the land that makes the wave break. So you got to ask yourself, if it has a shallow shore, is it going to break at the last moment, or would it break early on? Here. Would this break at the last moment, or would it break early on? Here. Would it break at the last moment, or would it break early on? Think about which one would it run into land the soonest. Okay? That's really what the question is. Where does it run into land the soonest? This is really just understanding wave geometry. Or geometry. Okay? So far people are answering it pretty well. Answer the question, because I want to move on. Okay, I need Noah to answer. You answered Noah? Okay. And we did okay. We could have done a little bit better. Let's make sure why we understand why it did what it did. Okay?
What?
The correct answer is A. Because look at the drawing. Look at the diagram. Waves break when they encounter land, right? Okay. So where are they going to encounter land at the last moment? Because that would be closer to the beach, right? Closer to the beach would be the last moment. Where are they meeting it at the closest moment? Well, it would be A, because A is going to be where the beach or where this land is the steepest. Okay, it's going to crash late. Here it's going to crash kind of early. This one's going to crash really early.
As you get smooth.
Okay, so it crashes based on where it meets land, and if the land is not very steep, it's going to crash way out there. Here's your next question. Assuming the seafloor drops off evenly parallel to the shoreline, predict how that will affect waves approaching the shore at an angle. So if these waves are coming in at an angle, what's that going to do to the wave? Okay? And this question is really asking you, what's the wave going to end up doing because it's coming at an angle? A is saying that the wave end closest to the shore will slow down and it cause the wave to bend this way. That's what A is saying. B is saying that the wave end closest to the shore will break first, causing the wave front to bend away from the beach. So that's saying that this one is going to break first, but then the wave's going to bend that way. Okay? C is saying the wave end farthest from the shore will speed up. So this is saying B is going to speed up, causing it to bend that way. Okay? D is saying the wave end farthest from the shore will break farther from the shore than usual. Okay? So B is going to break away before it gets there. And then E says there will be no visible difference in wave behavior compared to a wave approaching straight on. So this is saying it doesn't matter which way it approaches. There is obviously a correct answer. So pick one that makes sense to you. If you've taken physics, you know this answer. Because physics answers this question.
One. Good thing I'm taking physics.
Physics is very helpful. Do you have to take physics?
No.
You don't have to take physics,
Oh, wait.
but it depends on what you want to do in college.
Yeah.
If you want to have a science or engineering or any kind of science degrees, like health care, something like that, you're going to need physics. If you don't have a degree in any kind of science, then no, you would not need it.
I guess I'm.
I see.
Double major deck.
Let's.
Trying to double major, and get it in, so it's like. I'm pretty sure. I can find it. What? I really can't hear you, your voice is like. Yes. I'm tired. How long you staying for the film? You taking him to fall?
I think so. You need one?
So you won't be there that long?
Yeah.
I don't think the big club here, so you can start off with the match.
Okay, I'm ready to look at answers. Now, normally I would go a little bit further with this, but we are pressed for time. So the correct answer was alpha.
Oh,
Okay? Okay, A is gonna break first because it's gonna encounter the shore first. If it encounters the shore first, it's gonna break first. Okay? And waves are gonna bend towards if they're being slowed down. The only way they would bend away is if they were speeding up. B is not gonna speed up. Because when it breaks, it's actually gonna slow down. So the waves are gonna kind of bend this way. They're gonna kind of curl towards the shore in that manner. So A was the best answer.
why does it bend again?
Because as it encounters the beach, these waves are going to slow down because of the braking action. And anytime waves slow down, they will bend toward
The breaking.
what we call, in physics, you call it the normal, but they're going to bend towards the beach. Okay?
Answer.
Again, wave size is determined by the strength of the wind, the duration of the wind, how long the wind is blowing, and the affected area of the wind, which is called the fetch. So here's your next question. Surfers prefer Hawaiian waves over Texas waves because pick all that apply. And there are more than one. Fetch is how long the wind affects the wave. So if the wind can interact with the water for a long time, we call that a long fetch. Okay? And so it's saying that a longer fetch would mean bigger waves. Think about that. Does that make sense? If it makes sense, pick it. If it doesn't make sense, don't pick it. Okay? B says stronger wind makes more sediment. Okay? Okay. C says more sharks makes it more dangerous. D says stronger wind makes the waves bigger. E says lighter winds makes the waves more comfortable. Now, if you are a surfer, do you want big waves or small waves?
Big. My arms.
Okay. So I would pick answers that would work with that. You know, if I'm a surfer, I probably do want big waves. Okay, and if you see, this is Hawaiian waves and these are Texas waves. Okay, so pick all the answers that make sense.
So I get to work on PC.
Okay, Anna, have you answered?
I'm about to say.
Fatima, have you answered?
I'm going.
Brian, have you answered? Pablo, have you answered?
So you're not doing anything?
Well, answer.
Yeah, double major.
Again, it doesn't answer itself. You got to do it.
And then minor.
Double major?
Okay, let's see how we did.
It doesn't have that big of an issue.
We actually did really well.
Great graphics program, so I don't.
Oh, I chose A
Double
and B.
major and a minor?
Okay, well, the correct answers
Yes.
are alpha
See you in 5
and
years.
delta,
Woo!
because a longer fetch is going to result in bigger waves, and higher winds are going to result in bigger waves. Okay? The sediments in the water nobody cares about. They're not worried about sharks. And you don't want comfortable waves, you want big waves. So A and D are the better answers. Now, what is this image demonstrating to us?
How tides are formed from the gravitational pull of the moon.
Okay, now, the moon and the earth technically have a gravitational pull on each other. The reason why we see tides on our oceans is because we have water on our surface. The moon actually receives tides too, but its tides are not necessarily going to be water. It's going to be rock. Aaron?
So are we going to spell this for a sketch?
Not this part, but you do need to know this for the exam. So tides are going to affect and technically this could apply to your sketch because tides can affect the way sand moves, and the way sand moves affects barrier islands. Okay, so one thing you need to pay attention to is that when the moon is overhead, you are typically at high tide, or if it's overhead on the other side, you're at high tide. When the moon is on the horizon, because if I were standing here, I would see the moon on the horizon, you'll have a low tide where you are, or if I'm standing here and I see the moon on the horizon, you'll have a low tide. So when the moon is on the horizon, you're at low tide, for the most part. And when the moon is overhead, you're at high tide. Or 12 hours later, you're at high tide. For the most part. Okay? So here are some comparison photos. This is probably the Bay of Fundy, which I actually got to see the Bay of Fundy when I went up to Canada this year. I just didn't really get to see this. Because the further up you go into the Bay of Fundy, the more the tides are affected. They will have tidal differences of 15 meters. That's 45 feet. That's essentially the height of most of this building. They have tidal differences that are almost as tall as this building. Okay?
That's a whole.
It's Serena.
Whole disaster film right there.
Okay? So, we have different kinds of coasts that you need to be aware of. Hello, Serena. Do what? Okay. Did they not give y'all passes? Why wouldn't they? Confusing. So, you have different kinds of coasts. Submergent coasts are going to be ones where your coast is basically falling. But does the coast have to be falling to be submergent? No. The water level could be rising. So either one will create a submergent coast. Typically, this is, you're going to have estuaries formed in drowned river mouths because the water level is starting to overtake it. Emergent coasts are ones where the sea level is either falling or the ground is moving up. And ground can move up because it's being pushed up, or ground could be rebounding. Like when you had glaciers sitting on top of ground, what's that glacier weight going to do to the ground? It's going to push it down. If those glaciers then melt away, what's that ground going to do? It's going to rebound back. Okay? That's actually happening in like the Midwest area. Not the soil, but the ground, the actual rock and rock. Yeah. Yeah. It is kind of elastic.
I don't know what exactly.
Yeah. Not much, but it does rebound.
Like usually
I know.
rock, it's like hard.
Right. But I think it's probably more, maybe it's dealing more with the layers underneath, like this thenosphere. Because there you probably have a little bit more elasticity than you would with, but layers are being pushed down. So there is some elasticity there. I'm thinking it's probably going to be more this thenosphere. So emergent coasts are basically moving up, either because the sea levels are going down or the ground is moving up. You can also have depositional coasts, which tend to have lots of sand and deltas, and because they have sediment. Or you can have erosional coasts, which they tend to be irregular in shape. They don't have too many beaches, and they do have eroding areas. You can have convergent coasts, where coasts run into each other. These are typically these. So erosional coasts tend to come from convergent coasts. And passive margin coasts, that's like this side of the United States is a passive margin coast, because what is this coast doing? Which way is this coast moving? It's moving that way. Okay? What is this coast doing? It's moving that way, because what do we have in the middle? We have a divergent boundary known as the Mid-Atlantic Ridge. So that's a passive margin coast, and there you tend to have a broad continental shelf, and you have a trailing edge for your plate. So this is going to be divergent. This is usually going to be convergent. These tend to coordinate with these. So depositional coasts tend to be with these, and erosional coasts tend to be with these, for the most part. Okay? These are going to be dependent on rising or lowering water. Okay? Now, depositional coastlines do not typically have tectonic boundaries. They tend to be the trailing edge. They will have barrier islands, or spits, or lagoons, and the east coast of the United States is like that. Erosional coastlines do have tectonic boundaries. They tend to have uplift, okay? And this is the Pacific coast of the United States. Now, here is an example of a spit. Okay, here is your spit. It's coming off of your bar here. Okay, and here's an example of a spit right here. And it's basically a narrow deposit of sandy sediment that is attached to a larger area of land. So actually here, all of this is your spit. So sand moves this way because the longshore current is coming this way. Barrier islands can be, originally a spit that basically continued just onward. So sand is coming off of the land somewhere and is continuing on this way. Or it could be sand that's just accumulating and made an island, but it is a detached linear island made of sand that run parallel to the shore, and behind it you tend to have what are called bays or lagoons. And they can be full of marshes back here and tidal flats. Because this area tends to be an area where there isn't a lot of water movement. Here's an example of a barrier island that's been broken up. Okay? Let's see what your next question is, because I don't remember. Okay, here, I'll ask this one. This question that I'm asking now relates to the Texas coast. Okay, and I will tell you this. The Texas coast has barrier islands. So, where would you expect to see barrier islands? They're made of sand. And I'll tell you this too. Ocean waters are currently doing what?
Rising.
They're rising. So that should kind of tell you what kind of coast it is as well. Because ocean waters are currently rising. So you're going to pick more than one. We just talked about this.
Even emergent? Okay.
Mm-hmm. Here.
Oh, okay, we went through that.
So submergent is where your sea level is rising. Emergent is where either sea level is falling or land is rising. I can tell you right now, Texas is not rising. Texas is not rebounding or anything like that.
Ouch.
But sea levels are rising. Did you have a question, Tree?
Submergent coast, is that underwater?
It
Wait,
doesn't
what?
have to be underwater. It's
I'm
just
using
the
submergent.
Which is lower. Submergent.
submergent means that the water level is rising. So it may be.
So eventually.
It eventually will go underwater. It may not be currently underwater. It will eventually go underwater.
That's
And when it goes into water,
When
basically
basically,
go off.
so it's the coast that come from us spreading away.
It's something that's in the water.
Right. Okay, here's how you can submerge means that the land is being submerged by the water. Emerge means that the land is emerging from the water.
Diverting from other countries.
Okay? So you're talking about the land. If the land is being submerged, water is covering it up. If the land is emerging, it's coming out of the water. That's how you remember it.
Mid-ocean ridge.
Always think about the land. Because we're talking about the coast.
Emergent is when.
Okay, let's see what we put.
Sea levels.
Wait.
go down.
Wait, you should have answered.
No, I had them, but then I needed to submit.
Okay, submit. It looks like everyone's answered.
I submitted.
Most people got at least like 2 of them right, looks like.
What?
Yeah, tree got it right, because there were trees.
It's tree we're talking about. Wow, tree.
Yeah, I'm waiting for it to
I
respond.
knew it.
Everything.
No, I don't.
Oh, I got it right. Oh, I got A wrong, I got B right.
Okay.
Wait, yeah, I got it too.
So I was
Mr.
partially
Castro,
correct.
can you elaborate on the passive margin?
I told you my arm is short.
Yes.
I said it was like.
Okay, now are we listening?
Side of myself.
Are we listening?
I am.
Yes, but are we listening? Very good. Okay, so it's not an erosional coast because erosional coasts are associated with active margins, meaning 2 plates are running to each other. Texas is the trailing edge of the America coast, North American plate. So the North American plate and the Eurasian plate are doing this, right? Texas is on the trailing edge side. It's not on the leading edge side. It's on the side that would be the passive margin. A passive margin means it's not interacting with anything, okay? So it's also a passive margin coast because you have to understand what active margins would be. Active margins would be this plate is moving into this plate. So the west coast of the United States is an active margin coast. The east coast, which we are the east coast, is a passive margin coast because this coast right here is not running into anything. It's being pulled away. So it's not running into anything. That's what a passive margin coast would be. Something that's being pulled away from the other coast. And passive margin coasts will almost always be depositional coasts. Well, I said that we have barrier islands. What does that mean? There's sand. If we have sand, that's a depositional coast. These almost always go together. These, D and A, almost always go together. So you're either B and D or you're D and A. You're not really both. Yeah. And then we are submergent because the oceans are rising. Okay? So, these are the 3 that you should pick. Okay. And again, emergent means that your coast is coming out of the water or the water is going down. Submergent means that the water is rising or your land is sinking, one or the other. Okay? And these tend to go with these tend to go with these. So you need to know kind of what your coast is doing. But if you know your plate tectonics, you know what your coast is doing. And again, depositional coastlines tend to be passive. Erosional coastlines tend to be active. Okay, and we went backwards because I skipped a couple of questions. Here's your next question. Which of these factors do you think are important in the formation of barrier islands? So, I'll go back to barrier islands. They are linear islands made of sand. They're parallel to the shore. They can start as an offshore bar that builds up and then the sand tends to break away and it forms an island. Or they can start out as a spit that gets cut off from the original land. So they could be a bar that becomes an island, or they can be a spit that breaks away. So it depends on the way that they build. But I think I've sent that one out to you. So pick the answers that make sense. And again, I'll explain kind of what a bar is. So I'm going to look at a cross-sectional view of the ocean. Cross-sectional means we're looking at it from the side. So here is underneath. Here is my water level. Okay? So the two ways I can build an island is if I accumulate sand here, I get a bar that eventually becomes an island because you accumulate sand and you've made an island offshore. Or this is a bird's eye view. So if I have land that kind of does that and then maybe goes in like that, and I have a longshore current that's going that way, I can have sand kind of come off, come off, come off, and then if I break that sand there, like if a storm comes through and punches through that spit, I still have a spit here, but now I have an island. So that's the two ways that barrier islands can be made. Either because you split off the spit, or you have a bar. A bar is just an area out at sea where the water or where the sand accumulates. If the sand accumulates enough to be over the ocean level, then it's going to make an island. Either of these ways will make it. But notice, in both of them, you need sand. Okay? So let's see what we picked. Pick an answer. Did everybody answer? Because I'm seeing, if I look at it right now, according to the seat map, which is being very slow, the spinning wheel of death. Well, I'm ready. I'm tired of waiting on the... Okay, a lot of people like this because I was emphasizing sand, right? But a lot of people didn't like Charlie.
Oh no.
I picked Charlie and
You need Charlie because even though you have lots of sand that's moving around, if the sea level changes too much, what's going to happen is the islands won't stay. What if your sea levels go up too much?
It goes over
It's going to go over the island. So your islands can't form. So you need relatively stable, even though we have a submergent area, right now we still have islands. But if we continue to be submergent, what's going to happen to our islands? They're going to be submerged. We won't have barrier islands unless they accumulate more sand. Well, if sea level is falling, then what happens is you'll get dunes, but not barrier islands. Because the water would recede away from the ocean, and then you wouldn't have islands anymore. They would just be dunes. Okay? So you have to have a relatively stable coastline. Okay? Neither is changing. Okay? Now, you don't want land being uplifted because that's basically the same thing as sea level falling. Waves that are medium and large size, guess what waves are going to do to too big of waves? What are they going to do to our islands? They're going to break them down. And then storms do the same thing. Storms don't really bring sand. Okay? Typically what brings sand is just longshore currents. So storms usually break up islands. Keep that in mind. Okay, this is what a barrier island looks like. Why would this slide be really important? Right. This is what a sketch is probably going to deal with. So keep that in mind. If you want to study for the sketch, you have this slide. You're also going to be doing an activity in a moment that also is going to be basically this. You're going to be sketching it. But let's pay attention to what's here. You have bars that are areas where sand can accumulate. You have a swash zone where water interacts. The fore beach is the part of the beach where the water makes the sand wet. The back beach is the part of the beach where it really doesn't get wet unless there are storms. The berm separates them, You have smaller dunes that tend to not have vegetation, although they're showing it in the picture. But a lot of times Paphos dunes will not have vegetation. Vegetated dunes will. So what does vegetation tell you about a dune?
It's old,
Why do you say that?
because the plants have grown, it takes a while for them to grow.
Right. Plants need time to grow. It also means that the dune is stable. A stable dune means that it's not moving. Because if it's moving, what's going to happen to the plant? It's not going to be able to take root. Okay? So vegetation means you have a stable old dune, relatively old, right? Okay, then you also have vegetation back here. You have some island dunes that are on this side, and you get marshes and tidal flats on this side, because over here, we don't really get a lot of wave action, because this is the other side of the ocean, or excuse me, the other side of the island. This is the wave side of the island. This is the not wave side of the island. But you do get water moving in and out because of tides. So this is where you'll get creatures here that live off of the tides. They like this area a lot because there isn't a lot of wave action here. Okay? So you need to know your beach, dune, and barrier flats. Here is your beach. Here are your dunes, here, and then your flats are kind of in between your dunes. Okay, so beaches, you've got your forebeach here, your back beach here, and your berm here. Now, in this picture here, identify
The berm.
I didn't see the burn.
The berm separates.
identify the forebeach. On this image, you want to identify the forebeach. Okay? So I'll take you back a slide. Here be the forebeach. Here be the forebeach, right? Right here.
Okay.
Here is the back beach.
Yes.
Okay? So you should be able to figure out where the forebeach is based on the fact that is water interacting with it or not interacting with it? Did you answer it?
Yeah.
Okay. Is your question? Now I think in this image, in that it says all three things, but on your question,
The question is ask the forebeach.
yeah, it asks you to identify the forebeach. So pick where the forebeach is. Now, in a moment, we'll identify all three. But this question, you need to pick where is the forebeach. And you want to know where those things are for your sketch because you would want to label the areas of the sketch. Okay, I'm ready to show results. Has everyone answered? I'm waiting on Brian. Brian, have you answered?
Yeah, I just did.
Okay. So let's see how we did.
Yay.
82% correct. Couple of people picked the what?
The burn.
The burn. Well, it's behind it.
It's kind of borderline, right? You're right on the berm. Okay? So, this is the forebeach. What is our big clue for it being the forebeach?
Fishing.
It's wet sand. Wet sand is the forebeach. Where is the back beach? Dry sand. And where is the berm?
The line that
The
separates.
border.
Okay, that line that separates them. And often the berm, you can kind of tell where the berm is because it will be a change in slope. Okay, it'll be the change where the slope goes from more slope to less slope. Because you tend to have less slope with the back beach and more slope with the forebeach. Usually. Not always. The swash zone, the forebeach is part of the swash zone. I think you can even have swash zone that's not necessarily forebeach. There's a lot of overlap there. Okay, so swash zone is just going to be where the water is, but yeah, it's part of the forebeach. I think it can be further out too. There's not a lot of distinction where the water is. And it will vary. It'll vary where the forebeach is independent of tide. The swash zone is kind of tide dependent. Does that make sense? Okay. I mean, it's a good question. but the swash zone and fore beach overlap a lot. Okay? The back beach will get wet when? Right. When the water goes higher, and that would be during a storm. Okay? Now, dunes are going to be located on the landward and back beach side. So you've got dunes further back, and they are active if they are free of vegetation. Why would an active dune be free of vegetation?
Because it's unstable.
Okay, it's unstable. Plants can't grow on it. If it has vegetation, what does that tell you?
It's
It's
stable
old.
and
Okay.
different.
So Cobbles dunes are small mounds of sand that form an accumulation of windblown sand just seaward of the four island dunes. So Cobbles dunes are basically the first dunes that you see, and then the bigger ones tend to be your vegetated dunes. Okay? Barrier flats tend to be behind your dunes, and this is more where you'll start to see more vegetation. Now, I'm not going to send you this one, but which one would waves break first, A or B?
B,
Why B?
because there's a sandbar.
Right. This is going to make the wave break, which means these waves here are not going to be very big because they'll already have broken. Plants serve an important role because they stabilize the sand. Okay? And again, erosional coastlines tend to happen on the west coast. These are erosional coastlines. Okay? You tend to get cliffs. You do get some beaches, but not very big. These cliffs tend to erode away and form maybe small beaches down here, but not much. You don't have a lot of beach there. Okay? And you tend to get a lot of erosion here, so what's going to happen here? It's going to erode these things away to where these coasts tend to even out. So which one of these coasts is older? The bottom one or the top one?
The top one.
Why would the top one be older?
Looks more
It's shorter.
Right, it doesn't jut out as much. It's been more eroded. If it juts out more, it tends to be younger, on the whole. Okay, we have terraces here. What's probably going to cause these terraces?
Erosion.
You either have uplift of continental crust, sinking of crust, or rising of oceans. Which one of those is going to cause it?
Uplift of continental.
Right. This going up is going to make a terrace. Okay? Predict what will happen to sea level if rain fell continuously all over the world's oceans.
Sea level will rise.
What?
Where did the sea water, where did the rain come from?
I'll say C,
The
but
air.
it's still the same amount of water.
They would stay the same.
They would say the same. What causes sea levels to rise? It's not because
The
of rain.
ice melting and adding more water in the ocean.
Right. Glaciers melting cause sea levels to rise. Yeah, and they have to be continental glaciers, not sea ice.
I remember from physics that
Okay.
ice melting water.
Oh, and I you guys remember Miss Pfeiffer?
I just want to come say hi.
Hello.
Making my rounds, but it's nice to see you.
Are you off today?
I had to take off today because I had to take a test.
Ah, test.